The other possibility of obtaining oscillators is what is called as using phased lock loops, which is a revolutionary technique. All the cell phone revolutions are all happening because of this particular device called as the phase lock loop. It's a very interesting design where you can use this particular device as a frequency multiplier. That means if I have a frequency of, let's say, low frequency of 1 megahertz, and if I have a multiplier factor of 40, then I can get a 40 megahertz signal. It's represented by this symbol here. So this n need not even be an integer. It can even be a fraction. Yeah? There are fractional phase lock loops also available. But essentially, given a small frequency, you can boost it up to get a very high frequency. How is it done? Perhaps you can use an oscillator to first generate a reference frequency. Then you feed it to this essential device, particular device called as the phase lock loop. What it does is, there is a phase detector. That means it's a 3-port device where, depending on the phase of the input and this input, depending on the difference in their phase, the output will be either high or low, depending on whose phase is higher or lower. And if you connect that output to a VCO, voltage controlled oscillator, there is going to be a certain frequency that is coming out. If you go ahead and purposefully, rather than feeding it directly to the phase detector, if you go and purposefully divide that frequency by n, because multiplication is hard to do, yeah, but division is easier because the numbers get lower. It's easy for you to convert a 40 gigahertz signal to 4 gigahertz rather than converting a 4 gigahertz signal to 40 gigahertz. So you can divide easily by n. When you divide it by a factor of n, this feedback loop will try to maintain this signal, the so-called error signal, this error to be as little as possible. The difference in the phase of this and this error to be as little as possible. That means this signal must be as close as possible to this. If this signal is as close as possible to FREF, then before division, what I should have here is n times FREF. That means what my output of the phase lock voltage control oscillator has to be n times FREF. So naturally, you got a frequency multiplier by just dividing the output. So you're multiplying by a factor of n purely by dividing a factor of n and feeding it back, minimizing the loop error.